Hello guys, good morning and welcome back to my channel. If you are new here, may you kindly like the page, share the link, and also don't forget to subscribe on my YouTube video. You can also follow me on TikTok. All right, so today we'll be talking about complex numbers. So I'll just go ahead and give a quick introduction on complex numbers, right? A complex number, it is just any number that can be expressed in the form a plus bi, where a is the real part of the complex number and b is the imaginary part of a complex number. This is the imaginary part of a complex number. So quickly, we want to solve this quadratic equation. We want to solve x squared plus 2x plus 4 equal to 0. So I'll just go ahead and use completing the square method. All right, I'll separate the variable terms from the, I'll separate the non-variable terms from the variable terms, right? Then here, I'm going to add half of this, both sides, which is negative 4 plus 1 squared. Right, so x plus 1 squared equal to negative 3. So now we want to solve this problem here. So remember, when we square root complex numbers, we have a negative, and now we have a problem because of the negative. So that's when complex numbers comes into play, right? So you can rewrite this as x plus 1 equal to plus or minus. Then here it is just 3 times negative 1, right? Which is the same as saying x plus 1 equal to plus or minus square root of 3 times square root of minus 1. And now we are going to let I, an imaginary number, be equal to square root of negative 1, which implies that I squared is just negative 1. So that's an important property here. So x plus 1 equal to plus or minus root of 3i. So x will be equal to minus 1 plus or minus root of 3i. Hence, x is minus 1 plus root of 3i, or minus 1 minus root of 3i. Right, so these are the solutions to our equation there. Right, so one thing that we need to understand is that complex numbers here, they appear as twins, and these twins are called complex conjugate. Right, these are the same expression, they only differ with this middle sign here. One we have a positive and another one we have a negative. So in general, complex conjugates will be a plus bi and a minus bi, right? So this is what we call a complex number. So as you can see here, guys, you have the real part, which is the negative 1, and the imaginary part, which is root of 3, right? So now moving on with a complex number, we need to understand what is called the argument and what is called the modulus, right? But before we maybe go to that, I also want to bring to your attention that we can represent this complex number on a diagram which is called an Argand diagram. So an Argand diagram looks like the following. We have the real part and we have the imaginary part, right? So for the real part, we have my negative here. Then the imaginary part, we have the root of 3, right? So these two intersect here. So now this is my complex number. So we'll talk about this angle and we'll talk about this distance here in a few, right? So now we want to talk about the argument and the modulus of a complex number. When we say argument, we are talking about the angle of a complex number, where we'll be talking about the principal argument that ranges from negative pi to pi, or from minus 180 to 180 degrees. Then modulus is always what? is always positive. So we want to talk about this. Remember, when we are finding the distance, distance is always positive. Right. So now let's go back to our complex number here. We said a complex number is equal to a plus ib, where a is the imaginary, the real part that represents x, b is the imaginary part that represents y in this case. So if we are to represent this complex number on our Gantt diagram here, we are going to see that we have a here and we have b, right? So these two, all right, they intersect there. That's where our complex number is. So from this complex number, we are going to see that we have this angle here that starts from the positive x axis here to that terminal side. Then we just call this angle theta. Then from the distance from this point here to that is called the modulus, so we can represent it by r. Right. So from here, as you can see mathematically, that we have moved from here to there, we have moved b units, and here we have moved a units, and it's not a right triangle. And from what we know about right triangles, right, when I've got a and b, I can use the Pythagorean theorem, where r squared is equal to a squared plus b squared. So r is equal to a squared plus that, right? So when you are given a complex number, say r equal to a plus ib, right? When you're given any complex number z equal to a plus ib, to get your modulus, right, you simply square these numbers here, a and b. Don't worry about I. So it's just the square root of a squared plus b squared, and you consider the positive because we are dealing with distance, and distance is always positive. Right. Now we want to talk about the angle. But as for now, remember, since this is positive here, right, we want to find theta, and from the trigonometric ratios, this side here is my opposite and my adjacent. So I'm going to adopt the tangent ratio. So tan theta is equal to, always, I'm going to use this, right, the absolute value, right? This is just acute. So that's how we find theta. But you are going to see that the argument of a complex number, it changes depending on the quadrant in which it appears. So I want, in a bit, I just want to quickly explain about these quadrants so that we have a better understanding, right? So the good thing is if maybe z is equal to a plus ib, right, they are all positive. So this is quadrant 1. So in quadrant 1, we are all good to go here, right? So to find your argument here, you just say it's so remember from there, theta is just the arctan of this, right? Absolute of b over absolute of a, right? So when we're in the first quadrant, my argument is just theta. So my argument is just theta, which is equal to arctan of b over a, which is okay. Right, this is quadrant 1. But now the situation differs when we are now in quadrant 2. So in quadrant 2, it's just x will be negative, right? When it's like this, then the y coordinate will be positive. So it means when we have here and we have that, remember the argument is not this, that's our theta here. This is not what we are looking for. But our argument is the angle that starts from the positive real x-axis here to the terminal side. So this is what we are trying to look for. That's the angle that we need. So to get this angle now, obviously you know that our theta is here. So if you use our quadrant, remember this is a straight line is 180 degrees. So in this case, you can just say 180 or pi. So it's just pi minus, it's pi minus arctan of pi minus arctan of b over a. So in this case, remember, it's just 180 minus this small angle here. That's what we want here. So when we're in quadrant 2, we are using this one here, right? Then from there, we move on to quadrant 3. So quadrant, when you're in quadrant 3, right, it means they are both negative. So it will be like z equal to negative a minus ib, right? So when they are both negative now, this is the theta here that we calculate because our x coordinate is here and our y coordinate is there. So the angle that is being produced is this one. But obviously, like what I've said, if you are going anti-clockwise, it means this is what we want here, right? But this angle, as you can see, it's now more than 180 degrees. So we can consider this angle here. And you know that when we are going clockwise, our angles are negative, right? So it's just the negative of this one because literally this is the same angle. So when you're in quadrant 3, you just say negative of pi minus arc tan of absolute of b over absolute of a, right? Then if we are in quadrant 4, in this case, it means x is positive, but y is negative. So we are here, right? So x is positive, y will be negative here, right? So the angle obviously is this one here. That's our angle which we want. I mean, this is the our theta is here, right? But this is not the required angle. So our required angle, guys, remember, if we are going anti-clockwise, is this one here. But as you can see, this angle is already beyond 180, right? So you can consider this angle, but when you are going this way, it's now the negative. So it's just the negative of this one here. So when we are in quadrant 4, just know that your argument is just the negative theta, which is negative of arctan of absolute of b over absolute of a. So once you know this, you should be good to go. All right, let's consider the following example, right? So I just want us to find r and theta in each case. We want to find r and theta. So in case number 1, on case number 1, we are given z as maybe negative 1 minus root of 3i. Then number 2, z equal to negative 1 minus root of 3i. So let me make these two positive. So it's just 1 plus root 3 of I in that one. Right, so case number 1 is easy. You know that to find r, it's just the square root. To find r is just the square root of 1 squared plus root 3 squared, which is square root of 4, which is just 2. Right, and to find my argument, in this case, my argument is just theta, which is equal to arctan of absolute means positive y, which is root 3 over 1, which is just 60 degrees, or simply pi over 3 radians. Right, it's 60 degrees or pi over 3 radians. We can confirm that. In this case, it's arctan of square root of 3, arctan of square root of 3, right? And in this case, this is what 60 degrees, or if you put it in radians, it's pi over 3, right? Then let's consider number 2. So number 2, again, my r is just square root of 1 squared plus root 3 squared, which is just root of 4, which is 2. But we have a problem. So if you don't put the absolute value, that's where the problem is. This is a misconception here. Most students will make an error of saying theta is equal to arctan of negative root 3 over negative 1, and these negatives will cancel out, and they'll still get the 60 degrees, which is wrong, right? So what we can do is, first we need to identify the quadrant. As you can see that, okay, it is in quadrant what? It is in quadrant 3, so this is the angle that I want here. right? That's my argument here, though my theta is this one, right? So if you want, you can first calculate your theta, right? So my theta is equal to arc tan of absolute of this over absolute of that, meaning say it's just arctan of root of 3 over 1, which is 60 degrees, or pi over 3, or 60 degrees, right? So when we get this now, remember, if we are in quadrant 3, the formula that I gave you, it was just argument was equal to, depending whether you want to use radians or degrees, it was pi minus theta, but negative here. So it will be negative of pi minus pi over 3, which is equal to 2 pi over 3, right? Or you can use degrees by saying negative of 180 minus theta, which is negative of 180 minus 60, which is negative 120 degrees. And as you can see, negative 120 degrees is in the range between negative 180 and 180, though it depends with the question. Sometimes they will just ask you to write the answer within the range from 0 to 360, depending with the explainer. But one thing that you need to bear in mind is that the principal argument is always between negative 180 and 180 degrees. So guys, that's all about the introduction of complex numbers, right? I will see you in the next segment. Thank you.